Welcome to this April 19th edition of the Utah Data Engineering Meetup. I'm so glad you could come join us. If you haven't met me, my name is Mariah. I stole this meetup from Joe. I didn't have to do very much convincing. Joe just said, "Hey, Mariah, I'm busy." And I'm like, "Sweet, I'll take your meetup." So end of story. I am with the Forge Foundation. We sponsor several meetups. If you're interested in finding out more about our meetups, watching recordings of previous meetups, staying on all of the info, we have a great Slack channel, super active. It's the only way you can get a hold of Joe. The Forge Foundation, Forge Utah is a nonprofit that we've started about 4 years ago. It runs educational events for technologists. We have several meetups: Kubernetes, MLOps, Go, engineering leadership. We have the GoS conference. If you're ever in St. George, you can attend the one in St. George. We've also done workshops. We do everything. It's all recorded. There's a Twitter and a LinkedIn and a YouTube page, but most importantly is Slack. One, because Slack has the job boards that's super active. Two, it has a great data engineering channel that I post in. And we have great conversations about all aspects of technology, everything from hardware to 3D printing to how to build a website, which I don't do, but some people do. My last thing before I hand it off, we are just wanted to have a couple announcements. Thank you to Recursion for providing a space and pizza and a recording. Like I said, if you didn't get that QR code to join the Slack, which you should have all taken pictures of by now, we have a great job board there. I want to just give a little bit of time. I can put it back up.
Just leave it there for like a couple.
Okay. A while. Oh, perfect. I'll get out of your way. Is anybody hiring that they would like to share? Or looking for a job? You're looking for a job or hiring? Okay. This is Daniel. You can find him after if you're looking for a job.
I work for a company called ShorePoint. They work in cybersecurity, mostly government contracts, but they're hiring right now for various Azure roles and data engineers.
Hi, I'm Isla. I'm one of your hosts. Recursion is hiring. We are hiring for a senior data engineer for our data platform team. We are looking for a senior director of informatics, kind of a more specialized role, but potentially extremely interesting. And we're hiring I think it's a full stack software engineering position. So please check out our careers link on our website. Thank you.
Anybody else? Okay, also check out the jobs channel on Slack. There are more.
Everyone got this?
I'm getting off it now. Okay, I'll go back. If you would like to speak at our meetup, or you would like to host a meetup, find me. We are always looking for speakers. First time speaker, no problem. We help with all that. And if your company would like to host, just let me know. We're looking for a place next month. PyCon's going on right now.
Who's going to PyCon?
Is anybody going to PyCon? Woo!
The group over there. It's going to PyCon. DreCon, I spoke at that, but that's over now. So,
Oh, sorry.
yeah, it was a Dr. Dre's data conference.
They sent me an email today saying it was tomorrow, so.
Oh. It's a lot of kush they're smoking. So, weed jokes. All right. So, it's all fun. Yeah. So next month event, we're doing a real-time analytics workshop with Imply and Decodable. It's going to be good. So if you're into real time, it's going to be fun. We need a location for it, by the way. So, yeah, we'll sort it out. And then summer, right? So I think we want to kind of bring it back to locals. That's where we started. So some context, this meetup is about 5 years old now. It started back magically 5 years ago. Here we are today. And it started much as a very in-person local event, right? So I kind of want to bring it back to like the grassroots, at least over the summer. Because what happened in the meantime is it blew up. It became like an international meetup because it was online and everyone showed up, and the guest roster was insane, but kind of fun to bring it back to the grassroots. So that's the thing. So if you want to talk at a location, Mariah, I'll be gone a lot, but
just find me. And we're also going to do lightning talks. That's a really big fun thing. So if you don't want to give a full talk, but you have a fun project or solve the cool problem, or you just really like DBT, you can talk for that about 5 minutes. We'll have a lightning talk event over the summer. Matt works at DBT, so that's, oh, nice. Cool. With that, let's turn the time over to our speaker, Ryan. Give him a round of applause.
Oh, by the way, so we have copies of this book here. We'll be giving away copies. We have 10 copies, right, Matt? Yeah, well, I bought 10 copies, so I think. So the first 10 people who I would say are like really participating and asking questions and or harassing Brian either way, or heckling him, will be getting a second copy of the book. Incidentally, people who are helping responsible for our book are sitting back there. Just wave your hand. You can sign it. Yeah. So anyway, yeah, it's a full circle. So.
And if you have a question, I'll come find you with the mic. Just raise your hand.
Do you want questions before or after or during?
So this talk can be done in a half hour when I don't have this voice. When I do have this voice, it might take a little bit longer, and it certainly will take longer if questions come up in between. I don't care. If you are used to doing questions in between here, that's great. If not, if you want to wait, I'm cool with that too. The one challenge, I guess, is whether I'll cover it later in the presentation.
Okay, questions at the end. And then I'll find you with the mic. Okay.
Indecisive me today.
It's all you, Ryan.
There's also some ducks here at the front, and I'll let you guys get that at the end if someone doesn't throw them to you because you're doing a great job heckling me or something, and then you can get them earlier. Yeah, the ducks are a little hard. Like, don't hit someone on the head with them, but like, and there are also a bunch of stickers, and you'll see some of the stickers throughout this presentation, and the physical copies of them are up front. And now I'm just switching over in Zoom to share my screen. Yay. And this is one of the stickers that you'll find up there. All right. So this is removable, thankfully. This presentation is not a sales pitch on MotherDuck. I work for a company called MotherDuck. We will get later on into discussing MotherDuck briefly. I can wear this hat when I do. But MotherDuck is not launched yet, so you can't use it. You can't pay for it. You can't give us money. I'm sure you could find a way to give us money, but like, anyway, that's not what I'm here to do. It's not a recruiting drive. Our team basically is kind of heads down trying to prep for launching our product. And we're not really actively hiring except in a handful of specialized roles. But what I want to do is talk about DuckDB itself and kind of the context in which DuckDB came to life in this world, and has become, grown explosively, I would say, and a discussion on the open source DuckDB, why it's awesome, some of the internals, and a demonstration of the capabilities. And then I will talk about sort of the beliefs behind why we created MotherDuck, and why, we're creating a cloud thing off of what is an embedded database. So you'll learn some about that. First of all, if we go back in history, centralized compute. For those of you who are around in the 1940s to 70s and writing code, probably not many of you, but there were mainframes, and you could use this if you were at a large enough company or a wealthy enough academic institution. You just wait in line with your deck of cards for your program and a deck of cards for your data, and request execution, and you get the results. And that really introduced computing to the world. This was great in that they were powerful. Centralized compute had this shared access. A lot of people could use it, but bulky, expensive, not personalized. So then came along the PCs. Popularized computing because they were dedicated and personalized. And that was really why they became very popular, is because you didn't have to worry about impacting the work of others. You had your own machine, you could write your code and process your data, not worry about bringing down the system. Awesome. But that means also, though, that you have your own machine and you have the limits of your own machine. The cloud data warehouse today is very much like the mainframe. It is a shared environment configured to work best for the operators themselves and the average user, and not really personalized to the individual. Yet, as I'm presenting here, well, that's not a live updating thing, although I should figure out how to do that. I don't know if Keynote will make that possible, but I'm presenting here on a laptop that has 32 gigs of RAM, 10 cores, and sits 85% idle, maybe 50% idle on times I'm running Chrome or Google Meet. But it sits there idle most of the time, and this machine is capable of so much more. And so why can't we take advantage of that processing power for our analytics? And then a really cheesy joke, that would be just Ducky, wouldn't it? Enter DuckDB. So DuckDB is an in-process SQL OLAP database management system. If you can't tell, it was written by academics who wrote papers on this. And it was created at CWI, which is the Dutch National Computer Science Research Institute, by these two gentlemen initially, Hannes on the left and Mark on the right. They are the co-creators of DuckDB and the kind folks that gave me this sweatshirt. It is maintained by different groups. There's actually another entity that's not even mentioned here, but something about Dutch employment laws and stuff. But DuckDB Labs is their consulting company. They accept contracts to consult with people who are using DuckDB in their systems. And then DuckDB obviously has a wide community on GitHub, and there's a foundation as well, which MotherDuck is a member of. And the foundation has a number of corporate members that give $100,000, $200,000 a year to the foundation for them to hire more developers to work on DuckDB. So they've set up a pretty good system here to have a well-supported open source project. And if we break down what is a DuckDB in-process SQL OLAP database management system, the in-process thing is the part that scares people the most when they're thinking about, wait, why are you talking about using this for the cloud? That doesn't make any sense. It's in process and it runs inside Python, R, C++, and there's no external dependencies. The fun fact here is that DuckDB was actually created and inspired because of the R community. So Mark and Hannes had a lot of colleagues that were using R at their university, and they were, as database people, sort of disappointed that the R folks did not have access to SQL and did not have access to real databases as they were writing their code. And of course, they could access these things, but real databases had lots of overhead, right? On a standard basis, you had external connections. Usually you'd have the administration overhead, setting it up, installing it, all of that. And that's really why it became this, well, DuckDB was created, was to provide those types of capabilities to the R community. The same like SQL type capabilities, as well as the ability to just manage data outside of using like data frame type tech. And then it has expanded, and now it's probably more popular, in the Python community than in the R community. But that's really the origins of it. They wanted to create something that was in process, was super lightweight. It's 2 megabytes large, and has no external dependencies. Someone was asking me, like, if you're trying to use DuckDB with external resources that are served over SSL or TLS, you actually have to install an external extension. And that's really because they wanted to keep DuckDB super, super light, and probably didn't want to rewrite TLS, although they did rewrite Parquet and such to make it super light. It is OLAP, so it is meant for providing that full SQL support. It's meant for high performance aggregations. And I'll get later into what the structure of it is with columnized vectorized execution or columnar vectorized execution. But OLAP really just means that it is for analytics rather than for transactions. And it is often called SQLLite for analytics because of that. So, you can really think of it that way. SQLLite is a transactional version of this. SQLLite is probably the most installed and used open source software package out there, or in the very top of the list, or sorry, not very top, but in the top 5, let's say, of open source projects. And you don't hear about it day to day, right? It's not something that's obviously used, but everyone's mobile phone probably is running at least a few different SQLLite databases. A lot of web applications and other things are using them. A lot of other desktop softwares uses it. And sorry, this Y slide was actually my R community thing. I just got it a little earlier. But so DuckDB, I'm going to go into kind of the advantages of DuckDB in a couple different areas, the architecture itself, and then talk about how it enables simplified access to data. So the architecture itself, if you think about database engines, you have a couple different types of database engines that are common. Row-based typically are used for transactional data. The advantage here is they have a very low memory footprint. You're dealing with literally just one row of data at a time. Transactions often are updating a single row of data at a time. Great. It works well in that use case. It doesn't work well when you're trying to do analytics, because you're trying to load each row of the entire table, regardless of whether you're just accessing one column or 2 columns at a time. And if you have a very wide table, that's very expensive. Columnar, on the other hand, are optimized for those analytical workloads. You literally don't need to touch mostly like 90% of the data or something, depending on your table structure. You can just touch an individual column. And you can see later, I'm going to talk about the different types of data compression, or some of the different types of data compression that DuckDB supports. And having the data stored columnarily allows you to use data compression that makes sense for data that is alike, because most of the data in columns have more similarity with other data in that same column than other data in other columns. And then you have like the vector-based columnar execution engine. And really what this means is that it's still accessing data in columns, but it's accessing them in chunks. And by accessing the data in chunks of columns, what it can do is take advantage of CPU functionality like SIMD, simultaneous instruction, multiple data, basically running the exact same computations on each of those different chunks of data. It can also take advantage of cache locality. If you can make those chunks small enough that you can have them sitting in the L1 cache, for instance, here, then it's much closer to the CPU core. It's much faster to access, and then you can pipeline the data in, through the caches, and always be accessing the data super quickly. In the case of like an M1 laptop, that's actually my laptop sizes of cache. Most machines are much smaller than that. So DuckDB right now actually has this value hard coded, and they've just increased it over time. I'd certainly like to see the value of the size of those, the size of the vectors to be more dynamic based off of your CPU architecture. But we could actually fit quite a bit of those vectors in my L1 cache here on my laptop, and never have to take the hit of going to main memory. A lot of people think of DuckDB as an in-memory database. Even people who have worked with DuckDB think of it as an in-memory database. And frankly, it's weird, but it makes sense, because if you start DuckDB as a CLI, by default, you're using an in-memory database. However, you can start the CLI with DuckDB and specify a file name, and it has its own native storage format. So you can do queries that are larger than disk. It will spill over to disk to handle those queries. And you can store your data in DuckDB's native format, which will be much more optimized than accessing data elsewhere. The native storage format you could think of as sort of like a somewhere between a Parquet and sort of a Delta Lake or a Iceberg storage format. And what that means is that it is columnar, it is partitioned, but it stores an entire database. That's kind of one of their core requirements for DuckDB when they were working initially with this R community, is how do we easily share data between users? I don't want to have to share an entire S3 bucket to another R person who might not even have S3 credentials to access that bucket. I don't want to have 50 different files representing different tables, or even a lot more than that represent the different partitions in the tables. I want to just store one file and save and share one file. And so that's kind of the philosophy that they took. As we get later talking about MotherDuck, we're actually have an adaptation of this when we store the data on our servers. But for the original use case, the idea of not using a table per or a partition per file or a table per file actually just makes things a lot easier. And it provides ACID compliant updates, which like Parquet does not. That's why I was kind of saying somewhere between Parquet and Delta Lake or Iceberg. Compression algorithms. I mentioned that as one of the values of doing vectorized, or the columnar execution, and also the vectorized columnar execution, is the ability to have different compression algorithms for each of the columns. So this is one very simple compression algorithm where if you're literally storing strings in a table and those strings are always going to be duck or goose, in reality, you just need to have a lookup table and store a binary in the actual table. And then you can get a little bit more complicated where you say, okay, I'm storing strings, but I'm going to basically index off of the substrings and say that, dub always exists or exists a lot of times. So that's 0. Google is 2 in this case, and .com often exists as 1, et cetera. And again, it basically makes it a lot faster to store the data, but also a lot faster to read the data, and also a lot faster to do the aggregations on the data. And if you're using DuckDB, so DuckDB, like I said, there's a command line client, a CLI. We'll talk about some of the other things. There's JDBC drivers, a bunch of other stuff, but you could actually run a query on Pragma storage info on a table to see a particular table and what different compression algorithms are used. And you can see in this particular table, it's actually using different compression algorithms for many of the different columns. One of the reasons that DuckDB is very much a scale up, not distributed architecture. At one point, I worked for a company called Neo4j, graph databases. Anyone use Neo4j? Yeah, we got a lot of shit for not being distributed. And this is all over Hacker News in many different places. And they actually did a lot of work to fix that and make it work in a distributed fashion. But at the same time, computers have changed a lot in the last 10 years. And so, I'd say, hey, DuckDB is for normal size data. And what is normal size data? I contend, and we'll go into details, that the vast majority of the orgs in the world do not have greater than billion row data sets. And if you eliminate the complexity of dealing with a very distributed system, it actually makes it a lot easier to make an awesome user experience, which is what I think DuckDB has done. However, it could also work with larger than normal size data. This is a fun quote from Mim, who said, "The irony in life is I've never done a query on a billion row table, but when I did it, it was on my laptop using an in-process database." We'll get into some of the philosophies here, but like the vast majority of organizations and individuals aren't regularly processing billions and billions of rows. If you're the largest retail company in the US, what do you have? Like 500 million customers? I don't know what the current population is, but you have anyway. But for demonstration purposes, I'm going to actually show you some queries as they executed on a 1.5 billion row table, which is the New York City taxi trips from 2010 to present. And here I would argue is most times you would not need to run your queries on all the taxi trips from 2010 to present. You would build aggregates and store those aggregates. But again, for demonstration purposes, they are now available in Parquet format. And I actually did the animation on the slide as a real time based off of the time it took to run this query. It is about 20 gigs of Parquet files, which are like 1.5 billion rows, 20 gigs. There is compression going on here. There's also looking at particular columns that are happening here. But here we were able to query just a very simple SQL query on these Parquet files in less than 3 seconds, 1.5 billion rows. And the funny thing here is I'm actually not using DuckDB's native file format here. This is just purely in memory, loading the Parquet extension, and then literally just specifying files that are on my local disk with a glob pattern there to restrict it to 2011, 2012, or sorry, 2010 decade and 2020 decade. And then here is a slightly different one, except in this case, you could see I'm saying DuckDB taxis DuckDB. I'd already loaded the data into the native DuckDB format. You reduce the query time a little bit, but same result, same amount of rows. And that was on my laptop, right? That is on this thing that I'm presenting from. And then so I said, okay, well, what if I run this same stuff on EC2 machines? What do I get? And obviously this is taking advantage of the cores much more than the memory, because the data set's not that huge. It's 1.5 billion rows, but it's only 20 gigs of data. And we got down to 0.145 seconds on an M6i 32 machine here. So you can make this stuff run really, really fast on a single machine. And I'll get into a little bit later about the evolution of machines here, but nowadays, you don't necessarily need a distributed architecture for a lot of things. At some points, you should just say, you know what? The simplified version of this is actually better. And I know that is grating for all of us geeks that like to use the most complex systems possible, but it will keep our families happy if we're not paged in the middle of the night because we use the most complex systems possible. All right, so simplified data access. So we talked about performance, but one of the real values to me of DuckDB is how easy it makes it for querying your data, regardless of where that data sits. If that data sits on S3, if that data sits on your local machine, if that data is in CSV, if that data is a SQLLite database, you can now do, I forget whether it was SQLLite or Postgres. In the last release, they actually released the ability to not use the DuckDB format at all, and just use either a SQLLite or a Postgres database for all of your work with DuckDB. You lose some of the advantages of DuckDB, but like you gain other things in terms of compatibility with those other systems. But make it super easy. You can run it in process. You could do that command line client. I am trying to convince them to make installers that are a little bit more human-friendly installers and things like that. But you can run the command line client. You can also do in browser. And this is one of the things that's actually been used a lot by data companies is the WebAssembly version of DuckDB. So WASM or WebAssembly basically means that you could take that 2 megabyte executable of DuckDB and run it inside your web browser, inside your web application. So people are doing that, like Mode Analytics is doing that. Some of the other analytics providers are doing it server side and, and inside the web browser. But it makes it super easy to say, I can use SQL anywhere. If you like SQL, you don't have to suddenly change to using some, JSON operations or something like that. Once you're in your browser, you could just continue to use SQL. Excuse me. All right. So I mentioned it started as a project with the R community. I don't know R. I've written a handful of lines of R solving a bug for a friend of mine who was actually a genius using R, but he needed some new perspective looking at his code. And I somehow or the other figured it out, even though I didn't know what R was. But that happens now and then. You get a different set of eyes. But from a data scientist perspective, Pandas is also, a very popular library. And one of the things I want to talk about here is interoperability in Pandas. So let's say that you have a data frame up there, and you want to run SQL queries on it. You can do that with DuckDB. You basically just have your data frame, you register the name of your data frame, and all of a sudden here, your SQL query is not executing against the DuckDB database, but against that data frame that you just supplied to it. And you can even do much more complicated versions of this where you're taking data frames and joining them and unioning them or whatever with data that isn't a DuckDB database, and local data, remote data, et cetera. All of this stuff becomes pretty interoperable because it's all just considered different tables in the database. So SQLLite, the SQLLite extension allows you to basically attach your SQLLite tables as read-only views. So you could query as you normally would inside SQLLite, except that you could do it through DuckDB here. And why you would do that, it actually still is faster for aggregations I haven't looked at all the details about how they implemented it because obviously the underlying storage is still SQLLite, but they've made it faster for aggregations. I will say, meanwhile, the SQLLite team is actually advancing SQLLite, trying to make SQLLite work better for analytics. So, you should, of course, look at both at whatever time you go to implement things. But I could very easily see a lot of people using SQLLite as their transactional data store, and DuckDB for their analytics. Things get copied off over to DuckDB every so often in batches, but then you still access SQLLite and union that data in for sort of your live analytics if you're really trying to query against the most up-to-date data. Postgres also similar. You can query directly against Postgres. You can see at the bottom here is one of the ways that people often, can use these external data sources is really just to get the data into DuckDB, but to make a very easy SQL query that gets the data in, not using a bunch of different import and export utilities and things like that. You literally just say, you just copy the data in. And in this case, I'm not only just copying the data in, but I'm also saying I want to take that data from Postgres and make it into a Parquet file. And it's like, well, one long line. It's not much code there to basically say, I'm going to take a SQL query that executes against this other database, going to get the results, write it to a Parquet file. And this is the beauty of it all. You can access those Parquet files on S3. You could do it with specifying access keys and all. And today it's there with MotherDuck. We're going to try to build in more of a key store capability, but you can access your data from Parquet, or you can create your table in DuckDB. And with this one line here, create table trivia SelectStar from your Parquet file on S3. So, this is kind of the reason a lot of people like it, is no matter where their data is, whether it's in SQLLite or Postgres or Parquet files or CSVs on a remote URL, you can easily convert things back and forth. You can easily query directly from it live. So it's not just about performance. The performance stuff does provide an advantage when you're using the performant methods of doing these things. This is not the most performant method of doing it, but it provides that simplicity. The community also helps with that simplicity. It's a very wide contributor base. This screenshot was actually a couple of months ago. I'm kind of curious as to what it now is, but almost 200 contributors, a large Discord group. We've actually worked with an external community member, Marcos, who writes the DuckDB ecosystem news on a monthly basis with all the updates. And we have a Slack channel where we coordinate that with him. And oftentimes, we're only publishing a third of what people put in as suggestions for that monthly newsletter. It might eventually have to become a little bit more often than monthly, but and a lot of that is because of how quickly the community is moving, but also how quickly the DuckDB team is moving. One of the reasons we chose to work with the DuckDB team at MotherDuck is this fast pace of innovation, not only in the code that they're writing, but also in applying the latest research into DuckDB. We've seen cases where a paper is published on a new compression algorithm, and within a week or two on the main branch of DuckDB, that compression algorithm is implemented in DuckDB. And you just don't see that elsewhere except when you have these really amazing Dutch academics. So I just wanted to give you examples that, there's usually about 3 months between releases. They're doing these quarterly releases. This was release 0.6. And release 0.6 came out November last year. And these were the types of things that they had in it. Working in other databases, usually it seems to be a much smaller list of features, or at least less complex features that they put into a new release when they have releases this often. Then 3 months later in February, they added JSON ingestion, which I didn't even demo here because I haven't created that slide yet because they work faster than my slide creating abilities, I guess. But JSON ingestion, you can easily work with JSON files, query JSON files with SQL. It's kind of fun. Of course, other databases have that, but the ability for them to implement it so quickly is pretty amazing. You also have the ability now to attach multiple databases at once. And when I was saying about, I wasn't sure whether you could have a SQLLite backend or a Postgres backend sort of as your main store for DuckDB. It is SQLLite. It says so on the slide. So I wrote that and didn't remember it. All right. And they're looking at basically extending all the different SQL functionality. There's of course a regular debate over, do you make SQL better or do you make SQL standard? They've chosen to for now focus on the usability. So like if you just, often people will be like SelectStar from table. Well, the SelectStar is sort of redundant. If you just say from table, it implies SelectStar in DuckDB, which is just really handy. It saves you another couple characters, less carpal tunnel, all that jazz. And they're trying to make that more of that type of thing. So as a reminder, DuckDB was not created by MotherDuck. DuckDB was created at CWI by the DuckDB folks and maintained by them. MotherDuck is a member of the foundation and does pay DuckDB Labs to do stuff. DuckDB Labs is also an equity holder in MotherDuck. They do have a big chunk of equity, basically, so all of our incentives are aligned, but we operate as separate organizations. So you might wonder who the duck is MotherDuck. Why is this guy from MotherDuck up here talking about all this awesome work from other people? MotherDuck is a venture-backed startup. We formed together last summer with a group of folks. Our CEO was originally one of the founding engineers on Google BigQuery. I actually worked with him on BigQuery back then on the developer relations side. And that's how I got to know Jordan and how I joined. But there's a bunch of other folks from BigQuery. There's folks from myself coming from Databricks, Snowflake, Meta. Basically, we formed together sort of a rock star team from around the industry. And really, we want to make analytics a lot better experience than you have today. And not just for sort of the data engineers or the analytics engineers, but for your 9-to-5 data analysts that sit oftentimes not even in a central organization, they sit in marketing or they sit in a different business unit. We want to make their experience with analytics a lot better. So our beliefs are kind of founded on the idea that big data is dead. Let's focus on the ease of data rather than focusing on the size of data. We believe that by focusing on scaling up, we can eliminate a lot of the complexities in an architecture and basically still make a very fast and reliable system. We, of course, coming from places like Google BigQuery, my demos when I first worked on Google BigQuery were executing on 1,100 different machines every time I ran a query. Yeah, like we do see some of the value in distributed systems. It's just a value that a lot of people don't need in many cases. And so we're focusing at first, at least on the scaling up side of things with DuckDB. Your laptop is faster than your data warehouse. Why wait for the cloud? There is a sticker, as you saw, for that. But what, basically what we mean there is these two things should work together. It's not really that we should replace the cloud with your laptop, but you shouldn't have that computing power wasted. You should be able to use your laptop in tandem or in hybrid with the cloud. And then DuckDB slaps which is just apparently a new fangled term that I didn't actually know. But DuckDB rocks is what we would say back in the 90s or 2000s, but and let's supercharge it. So what is big data really? How much data do people have? And how much data do they query? The definition of big data, like this has gone on, ever since I started working, probably since 2006 or so, talking a lot about how much data is big data. Some people said it could be more than fits in Excel. So 65,536 rows at one point, I guess, became big data. More than can fit on your laptop seems like a reasonable definition, or more than can fit on one machine, more than can fit in one memory, more than can fit on one disk. The thing is that a lot of this stuff has changed. When I worked on BigQuery in 2012, the largest EC2 instance has 60.56 gigabytes of RAM. Today, the largest EC2 instance has 25 terabytes of RAM. That's 11 years, and we've gone 400x in the amount of RAM that is available to you to spin up a random instance in EC2. So things have changed, and we need to recognize that with that change, our definitions of big data, our definitions of when our distributed systems need to change. Similarly, when I worked on BigQuery, the largest MacBook Pro was 8 gigs of RAM. Now you have 96 gigs of RAM on some MacBook Pros. And not only has the compute gotten a lot bigger, data sizes, sure, like some people's data sizes have gotten big. When I speak in Silicon Valley, I would say that, 80% of the people in the room have terabytes to petabytes of data. Most other places in the country aren't at that place. Most other places in the world aren't at that place. And even frankly, it turns out that Silicon Valley isn't quite there. As much as the people who attend meetups are a little bit different. So data sizes, BigQuery, 95% of the customers had less than 1 terabyte of data. Single store, 80% of the customers want the smallest instance size. Gartner says most enterprise data warehouses are less than 100 gigabytes in size. Andreessen Horowitz looked at all their portfolio companies, and the B2B ones had less than 1 terabyte. B2C had less than 10 terabytes. So, people are designing for these large systems, but they don't necessarily have that large data. And even if they do have the large data, the data that they're querying should be queried from recent past, and is queried from recent past. People query data from today or yesterday, or this week, maybe this month. At most this quarter. So the vast majority of data is very infrequently used. And if it is used, it's often used inefficiently because you could have just produced aggregates. The data has stayed the same. Why are we recomputing it every single time? And when you get down to that is like BigQuery, 90% of the queries are less than 100 megabytes, meaning 90% of the queries that are running in BigQuery are accessing less than 100 megabytes of data. That doesn't mean that the tables that they're in aren't, tens of gigabytes, but they're accessing individual columns. And so just because you have this large data doesn't mean you need to use it. And you can also take advantage of partitioning and compression algorithms, pushdowns, et cetera, to reduce query sizes. I've already talked enough about this, but scaling out is difficult. The engineers that I've worked with have spent decades and decades working on consensus algorithms for distributed systems. What if instead of working on those consensus algorithms, they were working on the user experience and the interactions that people have with the data? So we say, hey, can big machines handle most workloads, eliminating the complexities of distributed compute? Just maybe. Data warehouse being a shared resources, it is often provisioned for average use and not running DuckDB yet. So if we get real, this is a very high level diagram of what we're building with MotherDuck. The difference here is the lightweightness of DuckDB. So on the right here, you have MotherDuck server, initially running in EC2s. I should say servers, ducklings as we call them, running inside EC2, runs DuckDB on it, obviously, but our clients are also running DuckDB on it. So, normally you're used to your JDBC driver not having the database inside of it. In the case of DuckDB, we can have the database inside of your JDBC driver, even if it's talking to the remote server. What that means is that you can do query parsing locally. And we have some of the world's best database researchers, Peter Bonds being one of them, who helped the folks at both Snowflake and Databricks, and was the PhD advisor for Hannes, who created DuckDB. He's working on this hybrid query execution research to say, hey, when can we take data to the compute, and when should we bring the compute to the data? Can we have this query planner that runs locally inside your driver, inside your client, inside your web UI, which makes that decision about where the data should be accessed from, where the computation should be done based off of current load and resource availability and things like that. That's kind of what we're working on. Is yes, it'll be an analytics service, serverless in the cloud, but you'll also extend a lot of that capability to the individual clients, and being able to execute things in both places, depending on what it is. This is the initial version of it, which is not as ambitious. There's a reason, they call it minimal viable product, or we try to call it minimal likable product. But if you look at that, basically what I'm doing is I'm able to actually connect. What you'll be able to do is, instead of specifying a file name, you'll be able to specify MD : as your location, which says, hey, you're on MotherDuck. Tino is our product manager. You'll OAuth into the database. Then you'll be able to create tables remotely. But you'll also be able to attach local tables and join data locally and remotely. So if you have a lookup table that's on your local machine, you have an Excel spreadsheet on your local machine, and you're trying to look at that data, in joined with data that's on your remote database, you could do that type of thing. So can query plans decide whether to bring the compute to the data or the data to compute? Hopefully. And then I end off with saying my laptop is still faster than your data warehouse, which actually is probably true in many cases, because like I said, people under provision their data warehouses because they're expensive. And that is all I have, other than giving you ducks and stickers and answering any questions you have.
Oh my. Are you, Joe and Matt will do the book stuff, so I'm not going to worry about that. We'll just start right here, Mark, and then I'll just go around in a circle. Okay.
Have you seen people using, or in what instances have you seen people using DuckDB in where it shouldn't be used?
Have I seen people using DuckDB where it shouldn't be used? I've seen people use DuckDB and expect more out of it than it is realistic at times. So, for instance, you can query remote S3 files, Parquet files, or TSVs. You can't expect like the blazing fast performance out of querying something over the network like that. So there's actually, quite a few people that complain about that performance, and I'm like, ask Comcast, don't ask DuckDB. But that is actually one of the advantages of building a cloud service where if the cloud knows that it has a fast access to the data, that query could execute on the cloud. And I lost. There we go. That's probably one of the areas. But honestly, I'm just impressed with how people are using DuckDB. A lot of the people today using DuckDB, I would still classify it as early adopters. There's, hundreds of thousands of downloads and stuff of DuckDB. But the people that are using it are very experimental. And so I've seen a lot of great things where people are saying, what if I take this 2 megabyte executable and my Lambda function allows me to have up to, I don't know, 20 megabytes of code in it. So let me run this across 10,000 Lambdas at the same time, writing out to S3 buckets. They're making, DuckDB into a distributed system, which is kind of awesome, right? So, as much as I want to simplify computation to make life easier for the average user, and to make it easier to build, products and features, some of this stuff is still amazing to me from a geek perspective. And so people have been doing that in all the different sort of Lambda providers. People have been messing around with Cloudflare's R2 and their kind of data at the edge stuff. So there's been a lot of really good experimentation stuff. I wouldn't say that I've actually seen a lot of stuff that I would say bad, because I think we're still in the phase of there's no bad ideas here. Let's play with the idea that we have this execution engine available in such a small size executable. Let's figure out what it can do. It's when people start, putting some of that into production and seeing, how well that they manage it on a day-to-day basis. That's when I might say, hey, come to MotherDuck instead of building this shit yourself. But for now, it's just fun to see.
So with OLAP databases or data warehouses, there's obviously a lot of data modeling that needs to go on in order to make things organized. And so does DuckDB support any sort of visualization to see those schemas or anything like that?
The short answer is no. I'm going to say one more thing to the last guy, and then I'll get to the longer answer of yours. DuckDB actually just released, DuckDB's always had extensions, the ability for you to write C extensions to DuckDB. They just released, I don't know, a month ago, 2 months ago, whenever Belgium was, a template library for building your own extensions. So that's where you'll start to see people doing things that are awesome, but probably wrong. And so I would check out what people launch as extensions, because there's a lot of fun stuff, but okay. So on the data model, no, there's no built-in sort of visualization capabilities or anything like that. But what you see is with folks like Hex and Mode and stuff using DuckDB and WASM on the client side, it does make it a lot easier to build those things in a performant way, which is what we really like about WASM is the idea of if I go into a Tableau dashboard, when I was at Databricks, I use Tableau to manage a lot of data. You change the filter and wait 30 seconds and you get the result. What I really like about DuckDB with WASM is that if the result set is pulled locally and you want to filter that result set more, it's instantaneous essentially, because you're executing that SQL query locally in your browser rather than sending it across the board. So I think it'll enable some new types of visualization experiences. Whether that affects the data modeling side, I'm not really sure.
So how far can you push this?
All the way, as fast as a duck will fly.
So for example, you talked about, hey, this is designed for normal size data, right?
Yeah.
Scenarios where you actually have big data, like petabyte size data sets, things like that. Tying into what you were saying about, hey, actually most of this data, you're not using all that data, right? You've got this concept of recency, and most of the data that you're going to be wanting to look at and access is going to be the most recent records, right? How much data could you realistically shove into a DuckDB instance before you start running into performance limits for other reasons, right? Is it basically the maxed out by the memory of the instance that you're working on, or?
I'd say it's a factor of the memory that is not an order of magnitude of the memory, is probably somewhere 2x or something like that of the memory. Again, it's going to depend on what is your disk performance and other IO factors. The biggest limitation that we've seen is sort of hydration of the data from, remote storage, because even today, most people don't use on-machine storage unless you're on your laptop.
Right.
You're using storage that's elsewhere. The hydration performance and the network bottlenecks there is probably the biggest limitation for realistic use cases today. And that's where distributed is.
Right. Right.
But I can't give you a specific number. I haven't pushed it quite that hard. But there have been, who was the like George Fraser from Fivetran did like a comparison against normal data warehouses that they see. And there are definitely cases where DuckDB wins. There's cases where it doesn't, depending on the size of the data warehouse. But he does a lot of interesting charts and analysis there that you should look up his blog post. But in terms of petabytes and stuff like that, at some point I would attribute it because of that access to storage challenge. And also, as you probably know, is if you have it in a single file for your system has limitations too on how quickly you can access that single file, or how large that could be depending on the machine and the file system. So I would say play with it and let me know, and I'll be happy to share to the next folks.
Okay, awesome. Yeah, so that actually ties into my second question, which is about the I work with multi-petabyte data sets, and I'm always trying to push people away from distributed things like Spark and stuff where possible because of the complexity overhead and things that you mentioned, right? I love the idea of using DuckDB to try and minimize some of that. And then in addition to that, like, hey, we've got our data lake. It's all Delta tables, Delta Iceberg. What is how much of a store? You mentioned that there's a internal file format for DuckDB. What sort of performance differential is there between, say, DuckDB's internal file format and reading from, say, Delta Lake files?
It varies. So it actually, like, they've published some things in the last month or so that unfortunately I haven't read them in detail, where like their internal file format got faster by multiple X in one. So it's advancing a lot, as are obviously DuckDB, as are Delta and Iceberg. I think they should be comparable in many cases, but it's going to depend on the individual queries. They all have actual database experts working on them. So, I think that's one thing that we'll see is just overall, like, to make fun of the marketing of one of my colleagues' former employers. Like they went out with some marketing saying like, our queries are 1,000 times faster than running on some data warehouse. And it's like, unless you've just like invented the magic bullet of computer science, like this is not true, right? Like, so, but yeah, I mean, you have seen some people do comparisons. Also, DuckDB does have an Iceberg extension in progress. And the Delta team has done stuff showing, basically with the arrow extension to Delta table translation, where you could just access the table there. And so the DuckDB folks are trying to optimize across all of this and recognize that their file format isn't the end all file format, but it's the same as they support, CSVs. They should support stuff that's a lot better than CSVs like Delta or Iceberg.
Absolutely. Awesome. Thank you.
I noticed on your release slide the mention of the recent addition of Upsert. I'm wondering, is there a level of ANSI SQL that it currently supports?
There's not a measured thing as far as I know in terms of ANSI SQL, basically where they try to align as much as possible to Postgres, because that's where a lot of the community is coming from, is using Postgres for transactional databases and accidentally stumbling on it for analytical use cases. But it does support the common analytical functions in many cases. Like I don't see often requests for XYZ SQL support as much as I see requests for other things. But I haven't seen a like true analysis, red light, green light on, ANSI SQL versus DuckDB. But I think you'll find it to be fairly complete. That's certainly a goal of theirs.
Okay. And second question, I had to step out for a second, so I may have missed it, but when you were demonstrating its ability to connect to the various storage systems, the command was install and load. For a second there, my brain was saying, is it installing Postgres inside of DuckDB? It's an extension.
No,
isn't it?
sorry, those are C extensions that it is installing. So DuckDB, because of that goal to keep it to a 2 megabyte executable, a lot of this functionality is external extensions, even if it's implemented by the core authors. And so the install and load that you saw there was literally just the extension for it,
To be able
the
to
C
talk to
bindings to
external, so,
go
okay.
to the Postgres libraries or whatever. And there's a set of extensions that are accessible that way and will directly load. If you build your own extension, right now they sign the core extensions, like cryptographically sign the core extensions, and you just load them like that. If you build your own extension, you could basically say DuckDB unsigned on this command line argument, and then any C extension you want. But yeah, it's not the entirety of Postgres, for instance.
Okay. Thanks, Ryan.
Yep.
You talked about the issue of whether data should be brought to compute or compute to data.
Yeah.
Can you explain what that means? I mean, I always thought of data having to be brought to compute. How does it work the other way?
How does it work the other way? How do you bring compute to data? If you think of it like, I guess, so in today's day and age, where you have very separated storage architectures, distributed storage architectures from your compute architectures, there's trying to think of like, realistically, yeah, you're always kind of bringing the data to the compute in those architectures. But it's, if you think of it more like, Google BigQuery, the way Google BigQuery worked was you have machines, like let's say these 1,100 machines. And again, this is Google BigQuery, how it worked 10 years ago. So I apologize if there's slight difference here, but I think it'll help answer the question. You have 1,100 machines. Those 1,100 machines know what storage they can access the fastest. And from a locality perspective of what zone they are in within the data center, or what maybe that data is actually in a different data center even. And so in those cases, it's kind of like you have the compute available close to the storage, and you're actually, you have a controller node here that is making requests to those 1,100 machines and deciding where the compute should be that accesses that data, which is kind of bringing the compute to the data in that case. But yeah, you could get fine lines on a lot of this, but the more realistic example, I guess, would be sort of day-to-day of cloud versus local, right? Like, do you download the data off the cloud to run the compute on your machine? Or do you say, I'm going to call the cloud and have that compute access the data? But yeah, if you look at the fine details, it's not as simple of an explanation as it might have made it seem in what I said.
That cleared it up for me though.
Just a quick question. Is the MotherDuck going to be like bring your own cloud, like your own EC2 instance, or is it you guys hosting it?
At this point, we're going to be doing it serverless. You will run basically the compute and the data will run in our EC2 instances. Eventually other cloud providers in all likelihood. But so today, yeah, it's not going to be running on your infrastructure or within your VLAN or things like that today.
Okay, and then next question, when you do the installing the extensions, like is the command, like at the beginning of your queries, does that do you need to do it every query, or is it up like the entire? Is it installed?
It's in
for
the
the
set,
entirety
it's
of the-
session based.
Okay.
So it's for the whole session.
Okay.
There is actually a DuckDB config file for the CLI that has been expanding in terms of its capabilities, and there's been discussion about enabling, always load these extensions type thing. And then we've also been discussing with the DuckDB folks about that and how it could, like, for instance, like if you have EC2 credentials or something like that, having those accessible anywhere DuckDB is running. But there's a philosophical question there. Then like some third-party tool uses DuckDB, should it have access to those config variables and going on there? But I think from a CLI perspective, you'll see that easy and be persistent. But for today, it's a single session.
Cool. Thank you.
So I've played a little bit with DuckDB. I'm curious on your examples that where you were loading data slowly and your queries got faster and faster and faster. Did you preload the data in the RAM on those? If so, how can we do that?
So I believe, yes, that I was running, well, in the cases where I didn't show me actually like the full SQL, there were times where I was running it a second time. DuckDB will automatically do that preloading. Obviously, it wasn't caching the results, so I wasn't cheating like that. But the data was probably in RAM for some of those. And basically, anytime you access data in DuckDB, it is automatically trying to use its RAM based off of, there is a config variable of, I think it uses up to 60% of the available RAM. I wonder if this is like my presentation remote interfering with it or something. Anyway, I think it'll use up to 60% of the available RAM to do that type of stuff. But yeah, that's in the AutoMagic.
Sorry, just one follow-up question to that. We've played with a lot of different storage types, obviously, like, local storage, like NVMe, right? Like SSDs, obviously, it can load from disk to RAM incredibly quickly, right? And so that's where you see the biggest results. I mean, with your sort of experience at MotherDuck, where have you seen sort of that transition? Because you're talking about like data serverless, and like, obviously you can go all the way to like, you know, there's like, network attached storage, and there's NVMe storage, and there's stuff that's ephemeral and stuff that's not. And then you're going out to S3 or object storage, or like kind of, can you talk to how, like, just a little bit, maybe your experience there?
Yeah, I mean, we're doing, I think it's EBS, the block storage on AWS today. And our number one optimization isn't for performance. As we get there, we have definitely investigated having our own basically EC2 machines with local storage, building a distributed storage network for storing the MotherDuck rather than having it on EBS. There's a cost advantage there, but there's also a significant performance advantage there from what we've seen. To know whether we're comfortable with that. But yeah, there's certainly, it's a what is the network bandwidth to the block storage versus what's the network bandwidth to other machines, and Amazon actually quotes different values for those things. And so that also goes into the machine type selection and all of that. But I think we'll get to the point where our storage will have to be on machines that we're managing, whether those machines are raw iron or whether they're EC2 machines or not. I don't know yet.
Sure. Okay, that makes sense. Just one follow because we've done a lot of experimentation with that as well. And we've seen basically, like you say, it's that first like initial load. It's getting that file across the network that generally is like that first initial delay, and then all of your subsequent queries sort of like get a lot faster.
Yeah.
Right. But yeah.
Yeah, I mean, it is certainly a challenge to figure out that how it's happening under the covers in ways too. Actually one of the guy who is running the storage stuff on our team actually wrote was the tech lead for all of block storage at Facebook. So he built all this stuff himself. And so there's a little bit of frustration, I think, there as he's like, using the vanilla off the shelf EC2 stuff. But that we need to launch. So that's what we're doing for now. But
Any other questions?
all right, don't all run for the ducks at once. And I guess these guys will figure out who gets books. No one heckled me too badly, so like I'm sorry they can't get books. Yeah. Here's your chance. If you'd like to target. Yes. For the ducks. Don't hit me on the head with the glasses.
1 minute. Mostly you're free to hang out and chat. Please come next month. We are literally right now working on confirming a location, so that's what Joe's doing. Yeah, I don't have anything else, so unless Joe does, you're good to go. Joe does.
Yeah, sorry. If anyone has a location for May 17th, let us know. We are crowdsourcing that. So thank you.